Okay, so again, we'll have this third example on area moment method. So from the given problem, determine the maximum deflection for the beam shown in the figure using area moment method. Okay, so as you can see from the given problem, it is a simple beam with a concentrated load of 120 kilonewtons, but unfortunately, the given load was not applied at the midspan. So it's applied at 10 meters from the left support and 5 meters from the right support. So wala siya sa midspan. Okay, so let us label first the beam. So say this is support A, support B, and let's say this is point C. Okay? So the elasticity is 200 GPa, that is steel. Tapos yung inertia niya is 700 million mm to the fourth. Okay, the first step is to solve for the reaction. Okay, so of course we have a reaction at A here and reaction at B. Most likely, of course, that would be upward. So let's say summation moment at A equal to 0. Let's say clockwise is positive. Okay, so we'll have 120. The moment arm is 10. Then minus RB. RB times moment arm is 15 must be equal to 0 for equilibrium. So from there, you could solve for RB. So that would be 120 times 10 divided by 15. So we have 80. So RB is equal to 80 kilonewtons, which is upward. Then summing up forces, vertical, equal to 0. Okay, so we'll have RA, pataas, plus RB. We solve it as 80, minus the pababa na 120. So must be equal to 0. So that would be RA should be equal to 40. So 120 minus 80 is 40. Okay? So after having the reactions, so again, let us draw the elastic curve. Okay. So the elastic curve would be the deflected form of the beam. Let's say the beam is perfectly horizontal before loading. So okay, so ganyan yan. So hinge, tapos roller. So horizontal siya before loading. Now, after the 120 kilonewton load was applied, let us assume that the deflection is like this. So okay, so exaggerate ko lang. Something like that. Okay? So, ibig sabihin, yung point A natin will remain at the same point. Yung point B natin will remain at the same point. Pero yung point C will be moving somewhere here. Okay? And so with that, let me assume that the location of the maximum moment is here. So, wala siya sa midspan. No? Hindi natin alam kung nasaan. So, let me call this as yan, say Y max. So, yan yung hinahanap. Y max. So, if I call this as Y max, let me call this the location Bx. From the left support, tawagin ko siya as X distance. Okay, so hindi natin alam parehas yan, yung Y max tsaka yung X distance. Okay. So how do we solve for the maximum deflection? Ano ba yung alam natin when it comes to maximum deflection? Diba alam natin na pagka maximum deflection, if we draw a tangent line at that maximum deflection, that is the lowest point of the elastic curve actually, diba? So if I'm going to draw a tangent line at that point, so the tangent line would be something like this. Okay? So ganyan. So ito yung tangent line. Tangent line at lowest point or at Y max. Ibig sabihin, yung slope doon is 0 kasi horizontal eh. Okay? So, ganyan yung mangyayari. Okay. Now, okay. So, we could say that, so how do we call this one? How do we call this one? this distance. Diba? This could be deviation of point B. Kapag yung tangent line is drawn at, tawagin natin yung lowest point at say at point D. At point D. Diba? Yan yung deviation. Likewise, dito rin sa support A, diba? Itong vertical distance na yan, that is also deviation of A when a tangent line is drawn at D. And they're all equal to Y max. They are both equal to Y max. Okay. Now, so what we can do here is, pwede tayo dun mag-start ng equation, no? Let's say, Y max is just equal to TA slash D, or it could be also equal to TB slash D. Okay? So, yan yung working equation natin. Now, okay, so let us draw the moment diagram muna by parts. Okay, so if we draw the moment diagram by parts, this is the M over EI diagram. Okay, so how would it be? Okay, so saan gusto natin mag-reference? Saan tayo magre-reference? Okay, so kung dito tayo magre-reference sa B, so our moment diagram by parts is due to 120, dito siya, so mag-create siya ng triangle na to. And that would be 120 times 5. 120 times the distance is 5. So we got 600. Sa baba siya, kaya negative 600. Yan. Tapos, yung reaction naman natin sa RA, yung RA natin is 40. So dito siya. Yung effect niya, pagdating do sa point B is ito. Okay, so that would be RA is 40. 40 times the moment arm is 15. Yan, 600. Sa taas, kaya positive 600. So, di bali ang moment diagram by parts natin, dalawang triangle. Okay? So, okay. Okay. So let's say, or pwede naman if you want, pwede rin yung dito tayo, pag dito tayo mag-reference naman sa pag nag-reference naman tayo dito, okay, so ang moment diagram naman natin would be 120 times 10. So dito siya. So dito, 120 times 10. Pag ganon. Okay, so that is negative 1, 2. Tapos, galing naman dun sa reaction, yung RB natin is 80, diba? So 80. Okay. So ito naman siya. 80 times that one. Okay. So we'll have 80 times 15. 80 times 15. So we'll got 1,200 din. Okay, so 1, 2 rin. Actually, parehas lang naman sila, no? Parehas lang naman. Kung alin dyan yung gusto nyong gamitin triangle. Now, so sabi natin, di ba, y max is equal to deviation of A slash D. Okay? So what is the deviation of A slash D? That is 1 over EI. of the area of the moment diagram between which points? A and D. Times centroid distance, sukat galing siya sa A. Okay. So, A and D. So, nasaan yung A and D? So, pagka pinroject mo yon, ang point din natin ito. Okay. So, ito kailangan natin. So, ito yung point D. Okay. So, ito yung point A. Okay. So, ito yung point A. Ito yung point D. So, kung ikukumpara mo, ano yung mas madaling i-consider na moment diagram? Yung unang moment diagram o itong pangalawang moment diagram? Okay, so alin dyan ang mas madaling i-consider? Pagka sinosolve natin yung deviation AD, so yung area natin na i-consider pagka itong first diagram is ito lang. Isang triangle lang. Pero kapag yung second moment diagram ang gagamitin natin, ang area natin between A and D is trapezoid sa taas, tapos trapezoid din sa baba. Di hamak na mas komplikado yung trapezoid. So with that, ito yung gagamitin nating reference or moment diagram. Okay, so paano? So that is 1 over EI. Okay, so kaya lang we need to identify this point. Okay, so let me call this as say Y. Y. Tapos ito yung X natin eh. Okay? So, i-relate muna natin. X is to Y, similar triangle, as to 15, di ba? 15 is to 600. Okay, so yung similar triangle over here. Okay, yung malaking triangle. So, X is to Y as 15 is to 600. So, from that equation, I could say that X is just equal to 15Y over 600. Okay, or that could be simplified as 1 over 40 or Y over 40. Okay, so going back here sa taas, okay, going back dito sa taas, so this becomes area of the moment diagram between A and D. And that would be the triangle. So 1/2. What is the base of the triangle? Ito, yung shaded area lang na to. So, okay, lagyan ko na ibang kulay para mas ma-identify natin. Gawin natin orange. So, ito yung area na kailangan nating identify. So, itong area na to. Okay. So, that is 1/2. The base is X. Okay. And the height is Y. Tapos, centroid distance from A. Okay. Yung from A natin yung kaliwa. So, that is 2/3 of X. Okay. So, yan na yung TA din natin. Okay. So, therefore, Y max is equal to 1 over EI. Substitute natin yung X. So, that would be 1/2. X natin is Y over 40. Okay? Tapos Y uli. Then 2/3 of X. Or maybe we have to express it in terms of X na lang. So, sorry. So, baguhin ko. So, that is 1/2 of X. Then Y. So, ito pwede natin express ng Y is equal to 40X eh. Diba? 40X. So, that would be 40X. Then 2/3 of X. Ayan. So, pagka sinimplify natin yan, 20, 40 over 3. Tama ba? 40 over 3 EI. cancel yung 2 kasi 4/3. Tapos x cube. Okay, so yan, di bali yung y max. Provided that we know the value of x. So ang problema natin dito is yung value ng x. Okay? So how do we solve the value of x? How do we solve the value of x? Okay. So to solve for the value of x, we could assume it, or we could equate it with TBD also, diba? TBD, or the deviation of point B with respect to D. Okay. So this is also equal to y max kasi. Okay, so that is 1/EI of the moment diagram between the area of the moment diagram between B and D naman. Tapos taken centroid distance about the first letter, about B. Okay. So dito, ang gagawin natin dito is mas madali, or if you want, pwede rin naman to, no? The same diagram. Okay? The same diagram. Or if you want, you could consider the second moment diagram. Either way, pwede naman eh, no? So tingnan natin kung ano yung mas magiging madali ba. Okay, so we're taking moment about B. Okay, so considering na lang yung the same moment diagram natin, reference tayo sa B. Okay? So, di bali, ang gagawin ko is, we have the trapezoid, di ba, yung right side. So, ang gagawin ko doon is, di-divide ko na lang sa triangle para dalawa. So, from here, i-divide ko siya rito. So, from here, i-divide ko siya sa triangle like that. Yan. So, di bali, may triangle ako dito sa taas, yung say kulay dilaw. Okay? Tapos, may triangle ako sa baba. Lagyan ko ng kulay green. Kulay green. Tsaka yung triangle natin sa baba, yung kulay pink. So we have 3 triangles to consider here. Okay. So isa-isahin natin. So that would be 1/EI. Okay. So let's have yung kulay dilaw. Yung dilaw na triangle sa taas. So the area is 1/2. The base is, kung x yun, so ano yung base ng dilaw na triangle? So tinawag natin x yung nasa kaliwa. So this would become 15 minus x. So 15 minus x. Tapos 600 yung height ng triangle. Okay? Tapos yung centroid distance niya galing sa B is 1/3. 1/3 ng 15 minus x uli. 1/3. Ayan. So yan yung para sa dilaw na triangle. Then plus, let us now consider yung kulay green. Okay, yung kulay green naman. Okay, so kulay green, ang area niya is 1/2. Ang base niya, ganun din, no? Base niya is 15 minus x. Tapos yung height niya, yung y. Ano yung y natin? 40 times x from here. Okay? Tapos centroid distance niya would be 2/3 naman, diba? 2/3 of the 15 minus x. Ayan. So, about B tayo eh. So, yan yung para sa green. Okay? So, tapos yung para sa pink. Okay, para sa pink. So, mag-add ulit ako plus 1/2. Triangle kasi siya eh. Base, ang base natin is 5. Tapos yung height niya is negative 600. So yan yung area nung triangle sa baba. Tapos yung centroid distance niya naman from B is 1/3 of 5. 1/3 of 5. So yan. So yan na di bali yung deviation of B/D. Okay, so and that is actually equal also to y max, di ba? Equal din yan sa y max. So pwede nating so let us call this as say equation 1. Tapos ito yung equation 2 natin. So pwede natin siyang i-solve ng y max equals y max. Or yung deviation AD equals deviation BD. Okay, so pwede natin i-equate silang dalawa. So simplifying natin, so that would be say 40 x cubed over 3ei equals, ano yung TB slash D? Ito yung mahaba, no? So 1 over ei. Okay, so simplify na lang natin. This would be 600, 300, 100. So 100 times 15 minus x. Dalawa silang ganyan, square. Okay? So, okay, then plus. Yung kulay green naman, that is, cancel yung 2. Cancel yung 2. Ang natira na lang is yung 3, tsaka 40. So, 40 x over 3. Ano ba? 40 x over 3 times 15 minus x squared. Dalawa silang ganun. Tapos, and sa third term, minus, constant na yan, no? So, that is 5 over 2 times 600 times 5 over 3. So, 25 minus 25. Ayan. So, from this equation, I suppose we could solve for the value of x. Okay, so try natin. So, yung EI, makakancel lang naman yung EI. 40 over 3 times x cubed. So, cubic equation siya. Okay. 100 times 15 minus x square plus 40 over 3 40x over 3 times 15 minus x quantity square minus 25. Okay, so yung expected x natin, of course, should be from, kung titignan mo yung figure natin, ano ba yung x? Yun yung distance ng maximum deflection measured from the left support, from A. So siguro medyo, kung 15 yan, so dapat ang sagot yan hindi nalalayo sa 7.5. And solving for that x, actually, ang lumabas na sagot natin is 8.16. 8.16, 49, 65. Yan, meters. So yan yung location ngayon from the left support. So yan yung pinaka-importante. So it is proven na wala siya sa midspan kasi ang midspan ng beam natin, kung 15 yan, 7.5 eh. So ibig sabihin, nasa bandang right side ng midspan. So with that, so knowing that x, so we just substitute x value in equation 1 or pwede rin in equation 2. So mas madali na sa equation 1. So in equation 1, okay, so our y max would be simply 40x cubed over 3ei. So substitute natin 40. Okay? So yung x natin 8.16, 49, 65 cube. Ang unit nito is kilonewton meter cube, no? Divided by 3. Okay, so what's E? Okay, what's the elasticity given sa problem? 200 GPa. 200 GPa is 200 GPa is actually 200 kilonewton per meter square. Tama ba? No. Mm square, sorry. Ayan. Kilonewton per mm square, that is gigapascal. Kasi yung Newton per mm square is megapascal. So pag ginawa mo kilonewton, magiging gigapascal yan. So that's equivalent to gigapascal. Tapos yung moment of inertia natin is 700 million mm square. 700 million. So 700 times 10 to the 6 million mm to the fourth. Okay? So, di bali yung kilonewton, maka-cancel lang. So, ang conversion factor lang natin dito yung meter. No? So, yung meter cube, kailangan natin siyang gawing millimeter cube. Isang metro is 1,000. So, cube. Ayan. So, that would give you the answer. So, let's see. Tama ba? Kilonewton, cancel yung kilonewton. Mm cube yun nasa numerator. Tapos mm square yun nasa denominator. Kaya ang unit ng sagot dito is millimeter. Okay, so times 40 times 1,000 cube divided by 3 divided by 200 divided by 700 million. Okay, so the answer here, solving for y max, would be 51.84105 millimeters. Okay, so this is the maximum deflection of the beam, 51 millimeters. So that's around more than 2 inches. Okay, so that would be the final answer for this problem. Okay, so again, I hope you have learned out of this sample problem. Thank you.